Hello to whoever's watching the video. You're amazing. I love you.
Wow. What a welcome. This is section 7.5, solving rational equations.
Sound more excited.
There are two main ways to do this. I will show you a little bit of both ways, and then I'll let you decide what you want to do. Basically, we have x squared over 3 plus x over 2 equals 5 over 6. We need to get common denominators because you cannot add these two fractions together on the left side unless their denominators are the same. So if we've got 3, we really want that 3 to be a 6. What do we need to multiply by? 2. So we multiply the top and the bottom by 2. The next one, it's a 2. We really want it to be a 6. So what do we need to multiply by? 3. So multiply by 3 on the top and the bottom. So now we have 2x squared over 6 plus 3x over 6 equals 5 over 6. If all of the denominators match, then all of the numerators are also going to match. So really, we can say that 2x squared plus 3x has to equal 5. Another way to think about that, if I were to multiply every single term of the equation by the same thing, then the equation is still valid. So if I multiply this first term times 6, this second term times 6, and this other term by 6, that would cancel out the fractions and leave us with 2x squared plus 3x equals 5. That would kill the fractions, basically. Some of what we're going to be doing today is fraction killing, which is going to make you very happy, I'm sure. Now we need to think about how do we solve 2x squared plus 3x equals 5. We need to get 0 on one side. So 2x squared plus 3x minus 5 equals 0. Most of you are getting really, really good at simple factoring. This one is not simple factoring. Do you see the 2 in front? When there's a 2 in front, what do you have to do with that 2? Multiply it by c. So we are looking for two numbers that multiply to give us negative 10. Those same numbers need to add up to 3. 5 and negative 2. Unfortunately, we can't just write x minus 2, x plus 5, because it's not a simple factoring problem. We take this polynomial and we split up the middle term. We split it into minus 2x plus 5x. If you were to recombine like terms, we still have 3x there. We've just written 3x in a unique way that's going to help us. How do you factor something that's 4 terms? Group it. You split it down the middle into 2 groups. What does that first group have in common? 2x. And a lot of you really benefit from the visual of saying divided by 2x to both of those terms. What would be left in the parentheses? X minus 1. What do 5x and 5 have in common? 5. So we're going to divide both of those by 5, leaving us with x minus 1. This means, I'm going to take this up here, I think, that our factored form is 2x plus 5 times x minus 1, and that equation is equal to 0. Now we get the fun part of solving. What's one of the solutions? 1. This one gives us x equals 1. Anyone remember the shortcut for how to find the solution for the other one? Take the opposite of the number, so negative 5, divided by the number in front of the x. This would be negative 5 halves. If you forget how to do that, take 2x plus 5, put it equal to 0, subtract 5 on both sides, Then divide both sides by 2. But your solutions are -5/2 and -1. Now, usually, it will not be that complicated to solve it. Usually, it won't require this kind of factoring, or it'll just require simple factoring. But we basically got common denominators to get rid of the fractions, and then got 0 on one side, factored, and solved. All right, let's look at example 2. Actually, we're going to skip example 2 because, why not? In example 3, the first thing that I would like to do is write this a little bit more spread out. We've got 3 over x plus 2. What do you suppose I should do with this negative? Attach it to that 1. So space yourself out. -1 over x. Space it out. Equals 1 over 5x. Let's talk for a minute about the denominators. What denominators do you see? Or more precisely, what factors do you see in the denominators? X plus 2. Anything else? Five. Our denominators, the factors in the denominator, we've got x. The x is in 2 places. We've got a 5. We've got an x plus 2. I am going to multiply every single term by those factors. So I'm going to multiply everything times 5 times x plus 2 times 5 times x plus 2 times 5 times x plus 2. When you multiply every single term of an equation by the same thing, the equation is still valid. Now we're going to become fraction destroyers, because how many of you actually like fractions? One person will admit to it. Definitely need another sign about we love fractions. Definitely. So let's destroy some fractions. In this first term, is there anything on the top that would cancel anything on the bottom of this first term? X plus 2. What we would have left is 3 times 5 times x, which is 15x. All right, let's go to the next one. Is there anything that might cancel in the next one? The x cancels, leaving us with -1 times 5 times x plus 2. So this is a -5 that we need to distribute. -5 times x is -5x. -5 times 2 is -10. Equals sign. It's a weird looking equal sign. What cancels in the next one? 5x. And that leaves us with 1 times x and 1 times 2, which is simply x plus 2. Does that equation look a little bit easier to solve than the crazy fractions? Okay. So we have 10x minus 10 equals x plus 2. We would need to subtract x on both sides. So 9x minus 10 equals 2. And then add 10 to both sides, so 9x equals 12. Divide both sides by 9. What is 12 divided by 9? Can we simplify that fraction? 4/3. First thing I'm going to do is spread this out. We've got 5x over x minus 2 equals 7 plus 10 over x minus 2. What denominator do you see? Just x minus 2, right? So I'm going to multiply everything by x minus 2. In the first term, X minus 2 will cancel, and we've left with 5x. In this term, nothing cancels, so we need to distribute. And then the x minus 2 cancels, and we're left with plus 10. Do you think you can finish solving that? Pause the video, take a moment, finish solving that equation. Anytime that your original denominators have x's in them, there's a step that we have to do to make sure that our solutions actually work. If we take this x equals 2 and plug 2 in right here, what is 2 minus 2? 0. Are we allowed to have 0 on the bottom? No. Zeros on the bottom are bad. You can't divide by 0. So this solution doesn't actually work. If your only solution doesn't actually work, then your answer is no solutions. So make sure you check your solutions. Just look to see, would this answer make a denominator equal 0? If it would, cross it out. If it doesn't, you're good to go. This example is not actually in your notes, but it is very worthwhile. We have 2 over x minus 10. I'm going to attach that negative to the 3 over x minus 2. And then what do you suppose we need to do with this thing? We need to factor it. We are looking for two numbers that multiply to give us 20 and add up to negative 12. So they must both be negative. Negative 2 and negative 10. So x minus 2, x minus 10. Now I look at the factors and the denominators. I see x minus 10. It's in there twice. And I see x minus 2. So we are going to multiply everything by x minus 10 and x minus 2. Then we become a fraction destroyer. In the first term, x minus 10 cancels. We then need to distribute to get 2x minus 4. In the next term, x minus 2 cancels. We need to distribute to get negative 3x plus 30. And in the last term, both things in the denominator cancel, leaving us with 6. To finish solving this, if we combine like terms, we have negative 1x plus 26 equals 6. So negative 1x equals negative 20, which means that x equals 20. Check your solution. Check both of your denominators. X minus 10. 20 minus 10, is that 0? No. 20 minus 2, not 0. And because both of those are not 0, right here, if we do 20 minus 2 and 20 minus 10, because both of those are not 0, when you multiply them together, it's not going to be 0, so you're good there as well. I can go back to this in a minute. In your assignment, I have crossed out a bunch of these, so look carefully. We are going to do number 8, and I'm crossing a bunch out. Number 22, number 30, and number 36. So just those 4 problems. If you're watching the video, if you need to go back to the previous example, I know the previous example wasn't in your notes, so rewind a little bit to go look at that example again if you need to.